When we talk about automation, programmable robotics, and artificial intelligence, we naturally think of them as the crowning achievements of our modern era. We know about these machines because Al-Jazari documented them in a text called The Book of Knowledge of Ingenious Mechanical Devices. Far from a philosophical treatise, this served as a practical, step-by-step engineering manual. Inside, he detailed the exact dimensions, materials, and construction processes for over 50 specific mechanical designs. He wanted other builders to be able to recreate his work. The central engineering problem of the 12th century was power. Without batteries or electrical grids, finding a reliable way to keep a complex machine running was a massive challenge. This 12th century diagram shows Al-Jazari's solution. To drive these heavy industrial mechanisms, he captured continuous environmental forces. Here, animal labor from the harnessed ox at the top provides the initial force, which is then transferred downward through a series of interlocking toothed gears. Al-Jazari focused on engineering self-sustaining mechanical systems, machines designed to operate continuously without a human operator. This is the original illustration of Al-Jazari's most famous invention, the elephant clock. On the outside, it was a massive, visually stunning set piece built to entertain members of the royal court, but that elaborate exterior was a misdirection. The decorative shell concealed a highly complex mechanism. Hidden inside its belly was the primary timing processor, relying on a precisely calibrated hydraulic float system. As the schematic shows, a small bowl floating in a larger water vessel was engineered with a tiny hole. It would slowly fill with water over exactly 30 minutes, until it became too heavy and tipped over. That tipping motion pulled an attached string, which then activated a cascading sequence of mechanical gears. This internal sequence eventually reached the top of the clock, prompting the machine to independently release a metal ball, or strike a cymbal. It delivered a precise physical signal at exact half-hour intervals. This process represents a physical feedback loop. By using gravity and water to regulate time and trigger a precise action, he proved that mechanical systems could manage their own timing and execution. He applied this same logic to even more complex behaviors, designing a floating boat that carried 4 mechanical musicians, programmed to play instruments entirely on their own. The continuous flow of water underneath the boat powered the core drive mechanism, slowly rotating a large wooden cylinder hidden inside the vessel. The surface of the rotating cylinder was covered in physical pegs. As it turned, they struck specific levers, pulling cables connected to the musician's arms. Remarkably, by rearranging these pegs, an operator could change the musical rhythm. Since the machine's output changed based on the arrangement of the pegs rather than the structure of the boat itself, Al-Jazari had created the world's first programmable mechanism. The instructions were physically integrated into the hardware. If a 12th century engineer successfully built programmable autonomous robotics, it raises an obvious question: why is his name absent from the Western history of technology? The historical record is heavily dictated by the survival of empires and geographic boundaries. Over the centuries, many of these mechanical concepts remained isolated, only to be independently reinvented and popularized by European engineers hundreds of years later. When we look at the manufacturing landscape today, we see massive high-speed industrial robotic arms assembling cars and factories operating with incredible complexity. While modern factories rely on digital sensors and high-speed processors, the core objective of automation connects directly back to this medieval workshop: the pursuit of machines that can execute a sequence of tasks through predefined rules. As we build an increasingly automated future, it is worth remembering its origins. The first lines of programmable logic were not coded in Silicon Valley. They were forged 800 years ago in Mesopotamia, with water, gears, and human imagination.